Here's a question on arithmetic sequences, right? And this might be something that you could encounter if you're preparing for the IB exam, if you're doing high-level maths. And if you'd like to see anything similar to this on the channel, let me know in the comments. So this question is a bit unusual. It's simply asking if there is an arithmetic sequence for which Sn, or the sum of the first n terms, is equal to this n squared plus 2n, right? So let's try to remind ourselves what an arithmetic sequence is, and then we'll try to work towards a solution for this question, okay? So I'm going to start by writing the first term, and I'm going to just make the obvious statement that a1 is equal to a1. Okay, that's the first term in the arithmetic sequence. Now the second term is created by adding a difference, d, to the first term, and then every other term is obtained exactly in the same fashion. So you add the same difference to the previous term. Okay, so this can also be written as a1 plus d, right? Because this a2 is a1 plus d, and then plus d again, which is a1 plus 2d. Okay, so each term can be found either by adding this constant difference to the previous term, or it can be obtained from the very first term in the sequence, and then you add an integer multiple of that difference. Okay, so let's try to compile everything into one column. So we have a1 is equal to a1, and then we have a2 is equal to a1 plus d, and then we have a3 is equal to a1 plus 2d, and we can write a4 if we want. So this is a1 plus 3d, and so on. So the nth term is going to be a1 plus, so if you look at how this works, a3 has 2d in it, a4 has 3d in it, so an is going to have n minus 1 times d. Okay, so using this we can actually find what the sum of those n terms is. So it's just a1 plus a2 plus so on up to an. Okay, so let's see what we have. In each term we have an a1, right? So we have a1 from top to bottom. So we've got n terms, and a1 appears once in every term, which means that we have n a1s. Okay, so this is going to be n times a1. And then we just have to add up the d. So we have the d, and then we have plus 2d, we have 3d, all the way up to n minus 1d. Okay, so that's going to be plus d times, so we factorize the d, and then we have 1 plus 2 plus 3 plus all the way up to n minus 1. Let's put this in brackets as well. Okay, so this is n a1 plus, and then we have d multiplied by, and we should know what the sum is, right? It's the sum of the first n, or the first n minus 1 numbers from 1 onwards. So this is going to be just n times n minus 1 over 2. Okay, and this is actually the general formula for the sum of an arithmetic sequence. And another thing we can do at this point is we can factorize an n, right? So this is n times a1 plus d n minus 1 over 2. Okay, now our question is asking whether there is an arithmetic sequence for which the sum is n squared plus 2n, the sum of the first n terms, basically. So let's actually try to equate those together. So we have this for the general form of the sum of an arithmetic sequence, and then we have this that we're trying to check if this thing is possible. Okay, so let's equate the two together. We have n multiplied by a1, and then we have plus d times n minus 1 over 2, and then this equals n squared plus 2n, right? But I'm going to factorize this as well as n times n plus 2. So I'm going to write this as n times n plus 2. Now remember that this is valid for any n which is at least 1. Okay, So what we can do is we can actually cancel out the n's because they cannot be 0. So this gives us a1 plus d times n minus 1 over 2, and that's equal to n plus 2. Right, so what I'll do now is I will, on the left-hand side here, I will try to separate the terms containing n and the terms that do not contain n. Okay, so we have a1 plus, now the other term that doesn't contain n is d times minus 1 over 2, okay, or minus d over 2. And the only term that contains n on the left-hand side is this one. So we just expanded the bracket, and that's going to be equals to n plus 2. Right, so n can be anything, right? That's what the question is asking, or n can be anything as long as it's at least 1. So we can actually treat this as a polynomial, right? Because if this has to happen for any n which is at least 1 and integer, it means that we can solve this as a polynomial, which means that this free term has to be equal to the free term on the other side, and also the coefficient of n on this side has to be equal to the coefficient of n on this side, which is 1, right? So we have a system which is essentially 2 equations and 2 unknowns. So we have a1 minus d over 2 is equal to 2, and then we have d over 2 is equal to 1, right? So the second thing actually tells us that the difference is equal to 2. And if we put this in here, we're going to get that a1 is going to be equal to 2 plus 1, which is 3. So the final answer to this question is yes. So there is an arithmetic sequence which satisfies this, and that arithmetic sequence has the property that the first term is 3 and the difference is 2. Okay, so this sequence looks like this. A1 is 3, A2 is 5, A3 is 7, A4 is 9, and so on. So it looks like those are all the positive odd numbers except 1. Okay, and then you can convince yourself that if you add up any number of them, you will get a sum which actually looks like this. Okay, and that's the end of the question.